Welcome back to another video in the Digital Logic Design series of videos. This is the next video in a sequence for the Verilog hardware descriptive language. And this time we want to talk about the different variable types that you can declare and use in Verilog. So let's go ahead and start by the very important first type, which is wire. Wire, literally, you can literally think about wire as being the physical wire that we use in hardware, designing hardware. And it's called a net data type because it can connect to the outside of the device you're doing. That's wire, could be an input, could be an output. So wire can be used to go in and out. Register is the other one, and we'll talk about it, reg, which is the difference between wire and reg is wire has no memory. It's just a piece of wire if you're implementing. Reg has a storage element associated with it. So because wire does not have any storage ability, it has to be always driven, constantly driven to have a valid value, which means that it cannot be on the left-hand side of an assignment inside an always block, because always block is not being executed all the time. Always is executed when something happens. So you got to make sure the left-hand side of the assignment, any assignment, and always is not wire is reg. But anyway, wire is used. So one example would be if we have an input coming in and our input is a wire. So there are different ways of defining it implicitly. You can say input is A and then come back and say wire A like this, or you can put them together. And if you got A, B, C, D you're defining, you don't have to do separate lines. Just say A, comma, B, comma, C, and semicolon, then you're done. Register type is very closely related to the net type or the wire type. The big difference is that register has a storage in it. So once you make an assignment, you don't have to constantly assign to value to it because it's going to remember. So you can use it in always and other places to do that, okay? So that's good. So an example of this would more like that. You can say output A, typically outputs are reg. Inputs are rarely reg. You want it to be wire. So input comes right into your system and then you can deal with it once it arrives. Outputs are reg because a lot of time because we don't want to be constantly driving it. We want to be make an assignment and then don't worry about it until you're ready to make a new assignment to it. So you can either declare these things like output A reg, or you can do output reg A. All regs do not have to be output and all wires don't have to be input. So you can create wires internally to use for internal to your system. But at minimum, you typically see the reg as an output and an input wire. You may have other wires and regs that are not input and output, but at least you will have some one connection out, otherwise your device has no connection in and out. The variable type, the type of things you can define inside, so you can control the flow or describe your behavior of what you wanted to do. These are very useful. Integer, of course, is the integer. In this case, it's going to be 32-bit. It's in a 2's complement format, so you have a positive and a negative integer in there. And to declare it, you just say the integer count, and you're done. You can make an initialization by saying equal to 0, equal to 5, and that's where it goes. Real is basically the precision floating point, and it's 64-bit, meaning it's double precision. So that's good. And the way if you have a fractional thing or you have a decimal point, you might want to use real, and that's how you do it. And then, of course, you have real time. You can get a variable type of time. You can also have a whole set of strings and sort of things that you can create as the type time to remember things and keep things as to get it. Okay. To store it for future use, whatever you want to use. Now, every one of the variables I described there, you can either make one variable or you can have an array of variables. In this case, is declaring grades to be a variable with having entities, having index from 1 to 20. So there is grade 1, grade 2, grade 3, grade 4. And when you use it, like if you want to grade 20, all you do is a grade, square bracket, open, square bracket, close, get 20, or if the font, you do this. Now you can also have a two-dimensional array or three-dimensional array, it really doesn't matter. In this case, you are having a real, which happen to be a GIS coordinate, which are real numbers. So you're gonna have 30, so you basically have created a grid that has 31 rows and 91 columns in this case. And so that's the dimension, and you can access it by basically saying real, I want row 1, column 2, and so say real, square bracket open 1, square bracket close, square bracket open 2, close, and you're done. Some, of course, you can use all of them, so you can create the, like if you have 16 bits coming in and you just want to declare a 16 bit, you just say input wire 15 0 or 0 15. The order doesn't really matter which you do it. It just depends on how it's arranged. So this would be a 16-bit coming in. If you have an input and output that you want to register, this is how it comes in. This is another way of saying these guys decided, from why I don't know, to have the index start at 13 and go to -2. Still 16-bit, but then when you refer to it, the least significant would be at -2, and the most significant is going to be in 13. Where in the previous case, if you define it 15 to 0, most significant is at 15, least significant is 0. Anyway, just different options available to you. That's pretty much as far as the types is concerned. You have the wire and the register, which have to be used for input and output. Internally, you have access to mainly integers, real time, and time as things that you can use to define variables inside. That brings us to the end of this video, talking about the different ways of defining inputs and outputs and variables in Verilog. See you next time.